The new part of it is the technique itself that we will be learning, and that technique is on how to make a solution. All right, so preparing a solution using a solid solute. So we're going to learn how we make a solution starting from a solid, and we're not going to just make any solution. It's not like we're making, Kool-Aid and we're just going to dump some water in with sugar. We want to make a very precise solution such that we know the concentration. Because if we're going to do a chemical reaction, we want to have precise concentrations so we know what we are making and what we are using, all right? So the lab itself is really a single calculation determining how much solid you're going to need in order to make the solution. That's the lab itself, very straightforward. The procedure is going to be the important part. How do you go about making that solution? And that's what I want to talk about here first. So preparing a solution from a solid solute, and let's write a few definitions down here. So what we want to define here first is something called a standard solution. And this is a term that we use to define a solution that we know the concentration really well, okay? And we're going to hopefully make a standard solution. And we're going to make it by dissolving a known certain mass in a very well-known volume. We can make a standard solution as well by diluting an already existing solution, right? So we could take the volume of an already existing solution and add some water to it. And we will be doing that lab on Monday, all right? We'll actually be doing the lesson on how we do a solution by dilution. We're going to do that tomorrow. I would have done the lab on Friday, but I'm away Friday for that specialist appointment. So we'll do the solution stoichiometry on Friday, and then we'll do the lab on Monday. We'll just flip those two lessons around. So we're going to make standard solutions. Different solutions that we already possess in the laboratory prep room, we call stock solutions. They are concentrated or saturated solutions that are pre-made that we can purchase at a known concentration. Typically, we take a stock solution and dilute it. That's tomorrow's lesson. And like I said, today we're going to take some mass of a solid solute and dissolve it in some water to make a standard solution. That is today's lesson. Now, it's all about measurement. We'll let you guys write. I'm doing talking when you should be writing. So, making a solution of a well-known concentration is all about our measuring techniques. We will be using two pieces of equipment, essentially. One to determine the mass. Now, the scales that we use for the grade 9s and 10s weigh to 1 decimal place, all right? Which means we can only know the mass to 1/10 of a gram. The scales we use in grade 11 and 12 measure to 2 decimal places, all right? That means we can know it down to the 100th of a gram. This is the most precise scale that we have in the school, all right? That means we will know the mass to as precise of a knowledge that we can possibly have. When I was in university, we used a scale that went down to there, all right? 4 decimal places. That's what's that? The thousandth, the 10,000th of a gram. Now, I guess you might ask, why don't we use a scale like that here? Well, the reason we let the grade 9s and 10s use the first type of scale is because they're about 150 bucks, right? You know, they're just a general scale that is quite reasonable. These scales that we use, they're about $400 to $500. All right, so we don't want the grade 9s and 10s sticking stuff on it, using, measuring their thumb and all that other crazy stuff that they will do. So we don't let them use it. But we are doing more precise work, so we use a more precise scale. Scales like these, oh, they're probably in the $10,000 range, all right? So obviously that's prohibitive for us to have just as a high school, but universities where you're doing very precise work, they can afford that type of thing, all right? So we're going to use the 2 decimal scale as precise as possible. The next thing that we have to measure is the volume of the liquid, because we're going to be diluting that or dissolving it in a solution. What did I do with my beaker? I could measure volume using a beaker. But a beaker, you'll notice, has a big wide mouth. So if I wanted to measure 200 milliliters in this beaker, I'd have to try to line the surface of that liquid up with that line, the 200 milliliter mark. It's difficult to line that big, large surface up with a little line that's on the side. Also, if I make a mistake and I put a little too much in, because of the large area of the mouth, a little addition will have a big volume because it's going to have a mistake that's that big around. So we need a more precise measuring device than a beaker. We could use a graduated cylinder. We've seen those. They're skinnier and they've got more markings. They're a little more precise. But these devices that I have on the bench here, the lab bench, are the most precise instrument that we use for measuring volumes. They're called volumetric flasks, and they're designed to measure 1 volume. You'll notice there's not a whole bunch of lines on them. There's actually just 1 line right there on the neck of this particular device. And the line is actually etched in the glass. I can actually rub my fingernail. I don't know if you can hear that. There's a little line etched right in. And that line, when you get the bottom of the meniscus, all right, now the meniscus is kind of that surface that the water makes, and it always makes kind of a curved surface. If this is the graduation line, the meniscus will look like this, and we want the bottom of the meniscus to just touch the line, and when we do that, we know we have exactly 250 milliliters, not like about 200 milliliters where we're not really sure exactly whether it's a little bit more or a little bit less. So the volumetric flask tells us exactly the volume we want. So we use our most precise scale to measure the mass, and we use our most precise volume measuring devices called volumetric flasks. And you can see here we've got all kinds of different versions of them. This is a 2-liter one. We've got 1 liters. This is a 500 mil. This is a 250. And you can see here we've got this little cute one here. This is a 10 milliliter volumetric flask. If you needed a tiny little amount of liquid for a particular, experiment, you could create your solution in this tiny little volumetric flask, and we would know that to be not just exactly 10 milliliters, it would probably be 10.0. We'd know it to 3 digits, all right, as precise as we can get. Now, a beaker like this, I can get a case of these, 12 of them, probably for 80 bucks. And for a flask like this, it costs about $60 or $70. So when I knocked it over earlier on, I was panicking a little bit. because I was just on the verge of breaking my $60 flask, all right? The reason they are so expensive is because they're precise. The manufacturing technique must be such that they know the volume is exactly 250 milliliters. So we will be using volumetric flasks. So how will we be putting this stuff together? What will we be doing? So at this point, we're going to write down the steps, and then actually I'll show the demonstration video at the end when we're done writing down the steps. So really? No. Throw that in the garbage. It's not coffee. It's throw it in the garbage. Yep, good. Okay, so I want you to write down the steps. A standard solution can be prepared from a solid solute by using the following procedure. There's actually 6 steps, so you can write this slide down, and then we'll get the last slide. And then I'm going to show you a little video that shows these steps very clearly, okay? Now, in the lab on Google Classroom, I've attached the video. So as you're doing the lab itself, if you forget a step, you could actually just watch the other person do it and do it the same way. All right, so you could observe the proper technique as you're making the solution. And I guess I shouldn't call it a lab because it really isn't a lab. We're not discovering anything. We're just making a solution. So the first thing you need to do is calculate the mass of the solid solute needed to prepare the required volume of the solution. And that's really all that the lab report is going to be. If you've opened up the document, you'll notice there's a couple of blanks where I'm going to tell you what solution to make and what the concentration is and what the volume is. You'll then do a calculation like we did yesterday to determine what mass you're going to need. You're going to then show me, or I can open it up on Google Classroom, and I'm going to approve it. Once I've approved it, you will then get your equipment out and you'll actually make the solution. The report then will just be the calculation. That's it. And I will just observe you making the solution. I suppose I could give you a mark for technique, but I'm not going to do that. This is the first time I'm running through it. I don't know how this is going to work. We'll see the way this works out, whether I mark them next time or not. Obtain the calculated mass in a clean, dry beaker. We're going to weigh it on some weigh paper. So I'm going to show you how to fold the weigh paper properly and how to get it on the weigh paper. You'll then transfer it to a clean, dry 150 milliliter beaker. You're then going to dissolve the solid in 10 to 20 milliliters of water. Notice it says 10 to 20. That's not a precise number because we don't need it precise yet. You'll just put a little bit of water in there and you'll swirl away to get it to dissolve. Don't use a stirring rod because we don't want some of that stuff that's dissolved to stick to the stirring rod. We're just going to swirl. And again, you'll see the video in a moment. Again, I don't know where we're at. Can I advance? Anybody waiting? Number 4, transfer the solution into the required volumetric flask. So you'll then pour that solution and you will use a funnel. Again, I'm going to show you the video on how we're going to do this properly. This video that I found comes from a college somewhere in the States, but it's an excellent video because it shows the technique perfectly. It's actually an excellent technique. So transfer it into the volumetric flask, rinse the beaker 2 or 3 times with small quantities of water, transferring the rinsings into the flask. So when you rinse, we want to keep all of that rinses in the flask. We want to get every last little molecule that was in that beaker, we want it to get into the volumetric flask. Again, I'm not sure. We still got writers, not a problem. I'm feeling a little rushed just because I don't know how long this is going to take. you know, I'm thinking maybe in the future I could have shown this yesterday, and then we would have been making the solutions now. I decided to do it the other way. We'll see. We'll be fine. That's the only reason I'm just feeling some tension, some rushing tension here. But I'll be patient. Let's do it. Sorry. Okay, are we good to go? All right. So these are the last two. Add pure water to the volumetric flask until the desired volume is reached. So you'll add it, and we're going to add it very carefully when we get to the end, right? So you're going to have a funnel, and you can pour some in from a beaker, but then when we get to the end, you've got to add it very carefully, all right? We're going to use a water bottle, which you have in your lab station, and we're also going to use a tiny little eyedropper, or like it's called a transfer pipette, and you'll slowly add the liquid until the bottom of the meniscus. And again, here's kind of a graphic representation. There's the bottom of the meniscus just touching that graduation line, all right? We call it a graduation line to represent where it's been marked. And then stopper the flask and mix it thoroughly repeatedly by inverting. So your flask will either have a glass stopper, which they work quite well, right? Which you'll just kind of hang on to, invert, give it a shake, right? That's how you mix it. Or if we've misplaced the glass stopper, you'll just have a rubber stopper. You'll put on snugly, inverse, give it a mix, and shake. Once you're done your solution, you'll then bring it to me, and we'll add it to the solutions that we use in the for various labs. Who's kidding who? I'm using you as student labor to make the solutions that we use when we do our other labs throughout the year. So I will thank you in advance for your excellent technique. They won't be. They won't be. What mark do you have at this point? 2. You have a mark of 2. Well then, yeah, I got nothing. All right, now I'm recording, but I'm hoping the video, actually, you know what, I'm going to stop recording at this point, and then I'm going to just play the demonstration video because I don't think it works together both ways. So I'm going to just stop this.